Now this study is going to be a little different because, as you can see, I've made this system a little bit more like a human pulmonary system. We've got a trachea essentially here, and we've got two main stem bronchi. So now I'm going to ventilate both of these lungs at the same time. I still have equal compliances, but I've got a higher resistance in this lung on the right. So it should take longer to fill and longer to empty. So let's take a look at what happens when I try to ventilate both of them. And what I said was true. The lung on the left with a shorter time constant fills and empties faster, and the lung on the right takes longer to fill and longer to empty because of the resistance. If I drop the compliance, in other words, reduce the compliance on this left lung, let's try it again. See the same thing, but now I want you to watch carefully because I'm going to give it a breath hold. So what happened? The lung on the left filled fast, but to not very much volume. But the interesting thing was it filled fast, and because it filled fast, the pressure in this lung went up fast. When I held the breath, pressures equilibrated. So gas actually went from this lung over to the slower to fill lung. That's called pendulift. So I'm going to do it a couple of times. First I want you to just watch the lungs. Then I want you to look at the manometers. The lung on the left is stiffer, so its compliance is lower. After I made my manipulations anyway, the compliance was lower. So at equal pressures, now if you look at the manometers, when I do the breath hold, the pressures become equal. As close as we can do with our uncalibrated manometers. They're both at around 15 centimeters of water. But the lung on the right-hand side is holding more volume because it's more compliant.